Welcome back, class. Now, if you've been on Facebook or social media for any appreciable amount of time, you may have come across a meme, a math meme in particular, where people essentially argue over how to perform a specific calculation. What you see over here on the right is one such math meme. We've got 6 divided by 2 times the quantity 1 plus 2. And of course, people will argue until the end of time over whether or not this quantity is equal to 1 or whether it's equal to 9. When you start to throw in negative numbers into these PEMDAS problems, the confusion only escalates. And so, who is correct? Or rather, how do we correctly go about performing these various calculations? Well, there are a couple of rules whenever you encounter a PEMDAS problem that will help keep your math straight. First and foremost, you want to write out your work in a manner which facilitates correctly calculating a solution. Math is useless if we just have symbols on a paper. Usually those symbols are asking the reader to perform a sequence of calculations. And if that's the case, you want to write your math in such a way that the calculations being performed by the reader are going to be performed in a uniform manner to begin with. And part of the reason that you have these math memes floating around on the internet is simply because the work is written in a manner which is intentionally confusing. So instead of, say, writing 6 division symbol 2 times 1 plus 2, we had instead written this problem as 6, a vinculum line, 2 times 1 plus 2. This would have been a much simpler problem for people to solve. And at least from where I'm coming from, the solution is much more apparent. Now, because the MyLab Math text is intentionally written to try to test your ability to understand that you need to rewrite the problems in order to get a correct answer, or in order to obtain a correct answer, the online text is going to write things out in the manner you see here. And what you need to know is that you're often going to be forced to take what is written and have to rewrite it in order so that you can see clearly what steps or what operations you need to perform. Okay, so write out your work correctly so that you can actually calculate a solution and you know that you've performed the calculations either correctly or incorrectly, assuming that you've written down your work in a manner that makes sense. Okay, the second thing that we need to understand about these PEMDAS problems is we really have to force ourselves to slow down. What we're testing you in this class and what we're trying to develop in this course is your conscientiousness, i.e., your ability to understand that each individual operation matters, and that if you, as many students do, approach these problems in a manner where you're doing 10 operations in your head and then 1 operation on paper, you don't necessarily know. In fact, there's no way to tell whether or not that particular answer that you're obtaining is going to be correct or not. And so you really, really want to perform one single operation at a time, and then you want to make sure that you're recording that single operation at a time. Now, what you'll see me do in this particular class is that as I'm going along, suppose I have a problem like 6 plus 2, the quantity 2 times 3. Well, what I'm going to do, if I decided that according to PEMDAS I needed to attack the multiplication first, I would do the multiplication operation, which is 2 times 3 gives me 6. And then I'm going to write my 6 down on the line below it. And the number and operation that I didn't perform, I'm going to rewrite that next to the value that I've just attained, so that now I'm ready for round 2, where I'm going to attack this 6 plus 6 operation, which should give me 12. And there you go. And because I only perform one operation at a time, and I only write down my work in descending order, I can backtrack and see pretty clearly whether or not my numbers make sense and whether I made a mistake somewhere. I would highly encourage students to adopt a similar line of thinking, even though it is more work. Obviously it takes more time for you to be conscientious. It takes more of a deeper level of thought process to be conscientious. So, that's what's being tested here. Now, the last thing that I will mention to students is that if possible, whenever you're presented with PEMDAS problems that incorporate negative signs, you want to make sure that you clear out the negative symbols. And the reason that you want to do this is you want to try to separate the calculation from the abstraction of the negative sign. So if you've got a problem like 6 plus -3, what I would do if I'm scanning through a PEMDAS problem and I see this positive and negative symbol is I'm going to go ahead and rewrite this positive and negative is a negative. So I can rewrite this 6 plus and -3 as a 6 minus 3, which gives me 3. Okay. I'm not going to jump and say, okay, this equals 3, even though I could do so, because while I might be able to do it in my head for problems such as this, if I threw at you 125 plus negative 543, you wouldn't be able to just jump to a solution. I don't think most students would be able to do that. So we have to slow down. We have to make sure that we write one operation at a time and that we clear out negative symbols and make sure that it's just a subtraction symbol. If you've got, say, a doubling up of negatives, and a negative negatives needs to be a positive, whatever the case may be, just attack those negative signs first if possible. Now, I have a couple of practice problems here just as examples, and they look rather nasty, but I want to show students that even though you've got a nasty looking equation or expression here, you can in fact find an answer and perform a calculation. We are going to need to remember PEMDAS to do this, but it's entirely possible for us to obtain an answer. Now, before we do anything, just take a deep breath, okay? Take a deep breath. I know a lot of students who see something like this following equation at the top, they're going to start getting a little anxious. Maybe their heart starts pounding a little bit faster. So we just need to take a deep breath and make sure that's not happening to us before we proceed. Once we're ready, we're mentally prepared to actually do this problem. We're going to start with the innermost set of parentheses. And note that we could be starting with parentheses or brackets. In this case, there are no brackets. We just have parentheses. But the innermost set of parentheses is going to be this 4 minus 8 operation. So 4 minus 8 should give me a -4. And all I'm going to do is I'm going to write down the -4. I'll rewrite everything else. You have to be a little bit careful here. And voila. So that would be step number 1. Step number 2, I'm going to scan through this equation and I see a doubling up of negatives. I see this -7 and a -4. Well, negative negative is a positive, and I could go ahead and clear that negative sign if I wanted to. Again, negative negative is a positive, so a -7 times a -4 would be a positive 7 times 4, or 28. Okay, let's move to the next page, shall we? Okay. Students should also know the following fact. While I could clean up this numerator, you could also equally work on your denominator. What we need to understand is that the numerator exists as this expression with all of these various numbers, and it's like the expression is wrapped in a secret set of brackets or parentheses. And the same is true for the denominator. So we can imagine in our mind's eye that there's a secret hidden set of parentheses or a secret hidden set of brackets. And because that's the case, while I typically will start at the top, students should know that we could start at the bottom. And either way, as long as we're performing our operations according to PEMDAS and they make sense, we should be able to get the same answer. Now, it does indeed look like the top will be a little bit easier. 1 plus 28 looks like it would be easier for me to calculate than, say, a -17 times 2. 1 plus 28 gives me 29. So I'm going to rewrite the numerator as 2 times 29 quantity squared, and my denominator doesn't change, so I'll just rewrite -6 minus 17 times 2. All right. Now we need to keep moving along. 29 squared. What am I going to do with that? How am I going to handle 29 quantity squared? Well, 29 squared is the same thing as 29 times 29. Okay. So we go down to the bottom of our page. We write 29 times 29. 9 times 9 gives you 81. Carry the 8. 9 times 2 is 18. 18 plus 8, what gives us 26. Okay. When you're satisfied with your answer, you can move to the next line. We'll give ourselves a 0. 2 times 9 gives me 18. Drop the 8, carry the 1. 2 times 2 is 4. 4 plus 1 gives you 5. Now we're ready for addition. 1 plus 0 is 1. 6 plus 8 gives you 14. One plus 2 is 3. 3 plus 5 is 8. So 841 should be our answer. So now we have 2 times 841 all over the -6 minus 17 times 2. When we go to attack this denominator, the only thing that we need to make sure that we don't do is we need to make sure that we're not subtracting 17 from the -6. Okay, the 17 is in fact multiplied by 2. So because multiplication has a higher precedence level, if we do indeed at this point in time want to move to maybe working with the bottom numbers, we just have to remember that multiplication has a higher level of precedence than the subtraction operation. So we'd have to start there. All right. Starting with the 17 times 2, or at least focusing on the 17 times 2 now. I'm going to ignore the fact that it's a negative because a negative times a positive is a negative. So we already know this calculation is going to be -6 minus something. Well, what is it subtracting? It's subtracting 17 times 2. 2 times 7 gives you 14. Drop the 4, carry the 1. 2 times 1 is 2. 2 plus 1 is 3. So we now have 34. So we have -6 minus 34 on the bottom and 2 times 841 on top. -6 minus 34 gives you -40. Because if I had $6 in debt and at a later point in time, I took out $34 of debt, I would have in total $40 of debt. Now, what we can do with the top numbers is we can figure out what 2 times 841 is equal to. So I'm going to put 841 and I'll multiply by 2. 2 times 1 gives you 2. 2 times 4 gives you 8. 2 times 8 gives you 16. So I should have 1682 all over -40. And that will, in fact, be a negative answer because you can treat the numerator being divided by this negative number as effectively the same thing as if you were to multiply a positive number with a negative. Okay, we'll see that there is in fact a relationship between division and multiplication when we get to the section on fractions. But at the moment, this is about as good as it gets. Okay, because we haven't gone over fractions. This is where you would kind of stop if you were not interested in, say, understanding what this fraction is equal to. In your MyLab math homework, they're not going to give you something that's this involved necessarily, but this gives you a good idea as to how you could attack a problem that was more involved. Okay, let's move on to problem 2. Problem 2 gives a great example of a problem that is not necessarily written in the best manner. So what we're going to do first as step 1 is we're just going to go ahead and rewrite this problem statement. I'm going to rewrite the numerator as being 2 times the quantity -3 squared minus 5 plus 11 times 9. And that'll be the numerator for my expression. And then where you see this division symbol, I'm actually going to draw the division as being this long horizontal line that we call the vinculum line. And I'm going to write 10 underneath. So This is our new problem. Now, giving ourselves a little bit more space to work with, I'm going to copy to the next page. Now, there's not much I can really do with this denominator. I hope everybody can see that the denominator really, it's just a single number, so there's not much I could do. So now we're going to shift our attention to the numerator, and using PEMDAS as a guide, we know that we need to focus first on anything inside of the parentheses. So we need to look inside of the parentheses in the numerator. And the second thing we need to do is focus in on the exponents, if any exist, and there are exponents that exist. In this case, we've got this -3 quantity squared, and this is where things can get tricky for students. Students should know that there are actually a number of ways that you can interpret this this symbol here, because I could interpret this as -3 quantity squared, or I could interpret this expression as -3 squared. Okay. Usually, usually the computer is going to want you to interpret this expression as being the quantity -3 squared. Because if they wanted you to know that it was in fact 3 squared, that was a negative, they would write it out like you see on the bottom here, but that's usually not the case. Instead, they're trying to confuse you because they know that students may not understand that there is in fact a difference between these two answers. The difference lies in what happens when you take -3 and square it. Recall that when you take a number and you square it, it just means that you're multiplying a number by itself however many times. So if I had 3 squared, that would be 3 times 3. But if I have a -3 quantity squared, that's going to be -3 times -3. Whereas with this bottom expression, what's happening is you're essentially slapping a negative symbol in front of 3 times 3. Well, if all we're doing is slapping a negative symbol in front of 3 times 3 is 9. So we would be left with a -9. But what's interesting is that in the top expression, because you've got a -3 times a -3, negative negative is a positive, you would then have 3 times 3, which gives you 9. So this is not this. Just so you know, we have to be very, very careful with how we interpret these expressions. All right, carrying on. We're going to, again, interpret this -3 squared as being the quantity -3 squared. And so we can rewrite that top expression as 2 times the quantity 9 minus 5 plus 11 times 9, all over 10. Cool? Moving on down the list, we now encounter multiplication, and we do have a multiplication operation inside of the parentheses. We've got 11 times 9. 11 times 9 gives us 99. Now we have addition and subtraction. Starting with this subtraction, 9 minus 5 gives you 4 plus 99. 4 plus 99 gives you 103. So we have 2 times 103 all over 10. Going down to the bottom of our page, we can calculate what 103 times 2 happens to be. 2 times 3 gives you 6. 2 times 0 gives you 0. 2 times 1 gives you 2. So 103 times 2 is 206. So this 2 times 103 divided by 10 is actually equal to 206 over 10. And that's about as good as we can get for this particular problem without diving into the topic of fractions. Okay? Now, we will get to fractions in this class, but we just can't do that right at this moment. All right, looking at this last example problem, we've got -30 times the quantity 4 squared all over -5 times -2 plus 10. And of course, the question that students will have is, how do we approach this style of problem? Well, we just need to remember PEMDAS. We could start with parentheses, but students are going to have an issue because while there are sets of parentheses here, especially in the denominator and numerator, there's nothing that can be done with the parentheses. And instead, what students should know is that sometimes the parentheses just exist to separate numbers out so that you can see the problem more clearly and perform the operations more clearly. If I wrote this problem as -5 times -2, you'll note that it's the same thing as this, but because there's this little dot operator and a negative sign, it's very easy for us to look at this problem and say this is actually -5 minus 2 if we're moving too quickly. As a consequence, I always require students to wrap their negative numbers in a sequence of parentheses. In fact, this problem would probably be best if we wrap the -30 in a set of parentheses and we wrap the -5 in a set of parentheses. That would probably add a little bit of clarity to the problem statement. It's not necessary in this particular instance, but it would add clarity. Now, because the parentheses in this particular problem only exists to try to separate out the negative symbols and highlight the negative symbols to the reader, we don't actually have to worry ourselves too much with the parentheses. Instead, we can go ahead and skip to exponents if we decided to do so. And you'll note that in the numerator, you've got 4 quantity squared. So 4 quantity squared is going to be 4 times 4, which gives you 16. So we'll have -30 times 16 all over -5 times -2 plus 10. At this point, we have a choice. We could do -30 times 16 if we wanted to. Negative and a positive is a negative. And then we would just have to do the multiplication of 30 and 16. Let's go to the side of our page. If we wanted to do the multiplication of 30 and 16, we've got 6 times 0 is 6. Sorry, 6 times 0 would be 0. 6 times 3, 6, 12, 18. We would write 180 on the first round. We'll drop a 0. We'll do 1 times 0 gives us 0. 1 times 3 gives us 3. And now we need to add everything together. 0 plus 0 is 0. 8 plus 0 is 8. 1 plus 3 gives you 4. So we should have 480 on top. And since there's a negative symbol in front, we'll have negative 480. Now in your denominator, negative and negative is a positive. 5 times 2 gives you 10. So you now have in your denominator 10 plus 10. Let's go ahead and focus on that denominator. 10 plus 10 gives us 20. So we'll have negative 480 on top, all divided by 20. We could stop right here. Or students could interpret this problem as 480 divided by 20 and perform the division 20 into 480. Note that at the end of the day, because you've got a negative and a positive, you will have a negative as a result. So when you perform this division operation, you'll have a negative something at the end of the day. Another thing that should be noted is that because we're taking a multiple of 10, 480 is a multiple of 10, and we're dividing it by another multiple of 10, we can actually do a reduction of this fraction, which we'll talk about when we get to the fraction section. We could actually rewrite this if we wanted to as negative 48 divided by 2. But say we didn't want to do that. Say we wanted to just go ahead and calculate negative 480 divided by 20. And the students, of course, will ask, how do I actually perform that division operation using long division? Some students would claim that it's not possible and that they need a calculator. I am here to tell you that it is indeed possible. To start, just like with regular division, you're going to write the number that's being divided, i.e. the 480, the whole part, underneath the L. You're going to take the bottom of your fraction and you're going to write it out to the left. So in this case, you would take 20 and write it out, 20 in front of the L. Now, what we ask ourselves is we say, not how many times does 20 go into 4, but how many times does 20 go into 48? Well, To answer that question, students should be prepared to try to do some multiplication, quick multiplication, to guess at how many times 20 can go into 48. 2 times 0 gives you 0. 2 times 2 gives me 4. So I might guess that 20 goes at least 2 times into 48. And indeed, 2 times 20 gives me 40. Because that's the case, I could write a 2 above. And when we back multiply the 2 with the 20, well, 2 times 20 gives us 40. Then we subtract. You're going to now do 48 minus 40, which leaves 8. Drop your 0. You would then ask the question, how many times does 20 go into 80? Well, you could count on your fingers, 20, 40, 60 if you wanted to, and then 80. So you could say 20 goes 4 times into 80 by just counting it. Or you could guess by using multiplication. You could maybe guess that perhaps it goes 4 times into 80. So you do the multiplication 20 times 4 on the side of your paper somewhere. 4 times 0 gives you 0. 2 times 4 gives you 8. And so, yes, indeed, 4 times 20 gives you 80. Then you do your subtraction, and you get 0 as a remainder. So negative 480 divided by 20 gives you negative 24. All right, guys, I hope that this is going to help you be able to work through the remaining portions of your homework problem sets. Take care.